Welcome to the Scikon machine learning tool tutorial. In this video, we're going to be covering ridge regression. So before we talk about ridge regression, let's kind of cover overfitting within linear regression. So overfitting is when a machine learning model is overly complex and fits noise within the training data. That training data noise adds details to the model that don't matter and results in a misrepresentation of the pattern within that data. And that causes the predictions on the new data to be poor and inaccurate. Some important terms to cover before we go on. Bias is error introduced by an oversimplified model, and variance is the error introduced by an overly complex model. So this is a visualization of the different types of models. An underfitted model is too simple, has very high bias, and doesn't match the pattern of the data very well. A model that is a good fit is appropriate for the data and shows the underlying patterns within it. An overfitting model is too complex, has very high variance, and misrepresents the pattern within the data. Ridge regression addresses multi-collinearity among the predictor variables. And this is when independent variables are highly correlated, resulting in unreliable predictions. This prevents overfitting by adding a penalty term that penalizes large weights. It simplifies the model and makes it less sensitive to random fluctuations in the training data by shrinking the weights or coefficients associated with the highly correlated features. The goal of ridge regression is to balance bias and variance so that the model can properly generalize on new data. As the model complexity varies, so does the bias and variance, and the model strives to find a place where the sum of the bias and variance is the lowest. To evaluate the model, you can either use coefficient of determination, which is r squared, which represents the proportion of the variation in the dependent variable that is predictable from the independent variable or variables. A good fitting model will result in an r-square value close to 1. Or you could use mean squared error, or MSE, which assesses model accuracy, average squared difference between predicted values and the actual values. Predictions close to the actual values result in an MSE value that will be very small. Ridge regression has multiple benefits and limitations. Benefits include a reduced MSE. It is stable in the presence of multicollinearity, and it retains its original predictors, which makes it easy to interpret. The limitations of ridge regression are that there are no variable selection, so you can't tell which variables are most important within the dataset. The model can become oversimplified, and it can be very computationally intensive to run. For our example today, we're going to be using phytomining data. So let's just briefly cover what that concept is. Phytomining is the cultivation of special plant species with the goal of harvesting them to obtain metals from soil. Machine learning can help predict tissue metal levels, biomass yield, growth patterns, and other factors. This is the Scikon machine learning tool. So to start, I already named my project, and I put in a short description talking about how I will be using Scikon to run ridge regression on my experimental phytomining data. For my data type, I've already selected tabular and uploaded my grass data CSV. For my target label, I've already chosen total rare earth element concentration. For my method, I've selected machine learning algorithm. For the actual algorithm, I've selected ridge regression. And for my evaluation metric, I've selected that r-squared value. So as you can see, when using ridge regression, that r-squared score is 1, And if you'll remember, an R squared value closer to 1 means that the model fits the data really well. So this is a successful model. Let's also run it using MSE as the evaluation metric. The mean squared error is also a very small value, meaning that the predicted values match the values within the dataset. This has been the Ridge Regression Machine Learning Tool tutorial. Thank you for watching.